Assalamualaikum. My group will be presenting the application of logic in real life, and our title is about traffic light system. We have 3 group members. The first one is our leader, Amirah Izzati binti Muhammad Nizal. Second one is Nur Asha Syafiqah binti Ayub. And the last one is Ifa Amirah binti Mustari. Let's start with introduction. Mathematical logic, also known as symbolic logic, is a system of reasoning that uses a standard set of symbols to represent relationships between the elements of an argument and to draw valid inferences based on predefined rules and procedures. Mathematical logic is one of the branches of mathematics that studies the principles and rules of logic in a formal mathematical context. It involves several operators such as conjunction and disjunction or negation, not implication, and biconditional. Each operator has specific rules that determine how various prepositions relate to each other and helps developing clear reasoning and logical analysis in various fields. Additionally, mathematical logic is also important in helping humans understand and organize thinking systematically and orderly to ensure that every decision made is accurate and consistent. In the fields of computer science, artificial intelligence, and technology, mathematical logic is essential because it allows humans to solve complex problems more efficiently and easily. By leveraging logical principles well, humans can design and develop more reliable systems for public use. Lastly, mathematicians who study mathematical logic also strive to identify and resolve contradictions and unanswered problems in this field, thus contributing to advancements in the world of mathematics and its applications.
Mathematical logic has wide-ranging application across various fields due to its foundational role in reasoning and problem-solving. Here are its key usages. In computer science, used in algorithm design, programming language, and artificial intelligence, form the basis for developing logical circuit, database, and software verification. In mathematics, help in proving theorems, establishing axioms, and analyzing mathematical structure. Ensure the consistency and soundness of mathematical system. In linguistics, assist in understanding the structure and semantics of languages through formal grammars and syntax. In everyday problem solving, improve critical thinking and the ability to approach problems systematically. Mathematical logic serves as a fundamental tool for advancing technology, scientific discovery, and analytical reasoning in diverse domains.
Now, let's move to description. Mathematical logic have 5 operations, which is conjunction, disjunction, negation, implication, and biconditional. The first one is conjunction. Conjunction happens when join two statements by an operand. In this operator, if any one of the statement is false, then the result will be false. If both of the statements are true, then the result will be true. It has 2 or more inputs but only one output. Next, disjunction. It happens when we join two statements by our operands. In this operator, if any one of the statement is true, then the result is true. If both of the statement is false, then the result will be false. It has 2 or more inputs but only one output.
3. Negation, or we can call not. Give the opposite statement of the given statement. It is also known as not. Denoted by tilde symbol, it is an operation that gives the opposite result. If the input is true, then the output will be false. If the input is false, then the output will be true. For example, P and not P, T, F, F, T. 4. Implication. If P is true, then Q is false. Then P then Q is false, otherwise is true. For example, P Q P then Q, T T T T F F F T T F F T. 5. Be conditional. If P and Q give the same truth value, then P if and only if Q is true, otherwise is false. P Q P P conditional Q, T T T T F F F T F F F T. Example 1. If Ali waits by the roadside to cross and press the pedestrian button to signal the system that he wants to cross, the vehicle must stop to give way to Ali. If the pedestrian light turns green, then Ali can cross. If the pedestrian light doesn't turn green, then Ali must wait, cannot cross. Therefore, if light turns green, then vehicle stop. P. Ali waits by the roadside to cross. Q. Ali press the pedestrian button to signal the system that he wants to cross. R. Vehicle must stop to give way to pedestrian. As pedestrian light turns green, T. Ali can cross. Premise 1. If P and Q, then R. Agreement. Ali waits by the roadside to cross and press the pedestrian button to signal the system that he wants to cross, then vehicle must stop. Premise 2. S then T. If pedestrian light turns green, then Ali can cross. Premise 3. Not S then if P and not T. If pedestrian light doesn't turn green, then Ali must wait by the roadside and cannot cross. Premise 4. S then R. Therefore, lights turn green, then vehicle must stop.
Now, let's move to example 2. The situation given is, if Ali presses the pedestrian button to signal the system that he wants to cross, then the pedestrian light turns green. If the pedestrian light turns green, then Ali can cross the road. From the situation given, P is Ali presses the pedestrian button to signal the system that he wants to cross. Q is the pedestrian light turns green. R is Ali can cross the road. From the statements given, we got two premises, which are premise 1, if P, then Q, and premise 2, if Q, then R. From these premises, using the rule of inference syllogism, we can get the conclusion if P, then R, which is if Ali presses the pedestrian button to signal the system that he wants to cross, then Ali can cross the road. Next, we want to find out if statement 1, if P then Q, and if Q then R, and statement 2, if P then R, is a tautology. A tautology means that every value in the truth table is equals to true. So first we need to create a truth table and input the values for P, Q, and R. From there we can get the value of if P then Q. Based on this table, only the third and fourth row is false because P equals to true and Q equals to false. So if P then Q will be equal to false. Next, find the value of if Q then R, and if P then Q, and if Q then R. Lastly, the value for if P then R. The last table, the last column, we combine the two expressions, if P then Q, and if Q then R, then if P then R. So the last column, all the values are equals to true. This means that, so it concludes that this equation is a tautology. Now let's focus to the last example. In this example, we need to determine whether if not S, then not T, and if S, then T, and if T, then S are logically equivalent or not. Given S is light turns green and T is Ali can cross. To answer this question, first step, we need to create a truth table. Next, input the value for S and T, and also for not S and not T, where either is T or F. Then, next we solve the equation for if not S, then not T. From the table, we can see that only the third one being F. Next, solve the equation for the second one, which is if S, then T. And the result is only the second one if F. The last one, solve the equation for if T then S, and only the third one is the result is F, and the last one solve the equation for if S then T and if T then S. The result is T, F, F, and T. So the conclusion is since the truth table for not if not S then not T, and if S then T, and if T then S are not identical, so the equation are not logically equivalent. For summary, logic influences our decisions daily. Mathematical logic isn't just theory, it's practical, forming the backbone of math, computer science, and real-world systems like traffic lights. It sharpens problem-solving skills, enabling systematic analysis, and is essential in fields like engineering, law, and technology.